Implementation of China's hypersonic air-to-air missile by 2025, a comprehensive overview.
Introduction.
In a significant move to enhance its military capabilities, China has announced plans to implement a hypersonic air-to-air missile by 2025 backed by a development budget of $15 million. This ambitious project is structured into 4 key phases focusing on the integration of advanced guidance systems and tactical deployment strategies. The development of hypersonic technologies is seen as crucial in the context of escalating global military tensions, particularly in regions like the South China Sea.
Key phases of development. Phase 1, Research and Development 2023. The initial phase commenced in 2023, focusing on extensive research and development R&D efforts. This stage involved conceptual designs and feasibility studies to understand the missile's potential capabilities and operational frameworks. According to various sources, this phase is characterized by integration of information sources, gathering data from existing missile technologies and integrating insights from various military domains to develop a comprehensive design. Feasibility studies, conducting simulations and modeling to evaluate the missile's performance under various combat scenarios. The aim is to establish a solid foundation for the subsequent phases of development. Phase 2, Prototyping and Testing 2024. Scheduled for 2024, this phase will focus on prototyping and preliminary testing of the missile's guidance systems. Key activities will include prototype development, creating a functional prototype of the hypersonic missile which incorporates advanced materials and technologies to achieve the desired speed and maneuverability. Testing of guidance systems, conducting a series of tests to validate the effectiveness of advanced guidance systems. Likely leveraging artificial intelligence (AI) and machine learning for enhanced targeting accuracy. This phase is critical for identifying potential challenges and limitations that may arise during operational deployment. Phase 3, Integration and Tactical Deployment 2025. The third phase will focus on integrating the hypersonic missile with existing military platforms and developing tactical deployment strategies. This will involve integration with airborne assets, ensuring compatibility with various aircraft platforms and enhancing operational readiness through rigorous testing. Tactical planning, developing operational doctrines and strategies for deploying the hypersonic missile in real-world combat scenarios, taking into account the geopolitical landscape and potential countermeasures from adversaries. This phase aims to ensure that the missile can be effectively utilized in various combat environments, providing a strategic advantage over traditional air-to-air missile systems. Phase 4, Operational Deployment 2025. The final phase targets full operational capability by 2025. Culminating in live-fire tests, conducting live-fire tests to demonstrate the missile's performance under combat conditions, validating its effectiveness and reliability. Final deployment strategies, finalizing deployment strategies that consider geopolitical tensions and the evolving military capabilities of adversaries, particularly the United States and its allies. Successful completion of this phase will mark a significant milestone in China's military modernization efforts, solidifying its position in the global defense landscape. Strategic implications. The development of hypersonic air-to-air missiles represents a critical advancement in military technology with profound implications for global security dynamics. Key strategic considerations include geopolitical tensions. The missile's deployment is likely to exacerbate existing tensions in contested regions, particularly the South China Sea, as it challenges the air superiority of the U.S. and allied forces. Countermeasure development. As hypersonic technologies evolve, adversaries will be compelled to develop countermeasures, leading to an arms race in missile defense technologies. Shift in air combat strategies. The operational deployment of hypersonic missiles may necessitate a re-evaluation of air combat strategies, emphasizing the need for advanced air defense systems and tactics to counter such threats. Conclusion.
China's hypersonic air-to-air missile program, structured into 4 key phases and backed by a substantial development budget, reflects a strategic commitment to enhancing its military capabilities in a rapidly changing global landscape. The successful implementation of this missile by 2025 could significantly alter the dynamics of air combat and necessitate new countermeasures from adversaries. As military technologies continue to evolve, the implications of such advancements will be felt across the globe, shaping the future of warfare and international relations. The content regarding China's hypersonic air-to-air missile development by 2025 presents several counterintuitive insights that challenge common perceptions. Here are the key points. 1. Development budget versus technological complexity. The implementation of a hypersonic missile by China is backed by a comparatively modest development budget of $15 million. Given the high costs typically associated with advanced missile technology development, one might expect significantly larger budgets to achieve such ambitious goals. This disparity suggests that China may be utilizing innovative cost-saving measures or leveraging existing technologies more effectively than anticipated. 2. Phased development approach. The project is structured into 4 phases, including design, testing, integration, and operational deployment. This phased approach implies a systematic method that contrasts with the often chaotic and rushed timelines associated with military technology development. It suggests a disciplined strategy that may allow for more thorough testing and refinement, potentially leading to a more reliable end product despite the aggressive timeline. 3. Focus on AI and machine learning. The emphasis on integrating advanced guidance systems, particularly those employing AI and machine learning, indicates a shift away from traditional missile guidance technologies. This reliance on AI could lead to unexpected advantages in terms of adaptability and targeting precision, but it also raises concerns regarding the reliability and ethical implications of autonomous weapons systems. The assumption that traditional guidance systems are superior may be challenged by advancements in AI-driven technologies. 4. Geopolitical context and implications. The development of the hypersonic missile is situated within a rapidly evolving geopolitical landscape, particularly in contested regions like the South China Sea. The strategic emphasis on hypersonic capabilities reflects a broader trend in military modernization that may catch adversaries off guard. The expectation that traditional military power balances will remain stable could be undermined by the disruptive potential of hypersonic technologies. 5. Comparison with U.S. capabilities. The narrative suggests that China's rapid advancements in hypersonic technology are a response to perceived shortcomings in U.S. military capabilities. However, this can be counterintuitive, as it challenges the notion that the U.S. remains the unassailable leader in military technology. The idea that the U.S. might be lagging behind in this critical area introduces a paradigm shift in the understanding of global military dynamics. 6. Public versus military knowledge. The varying levels of detail available across different sources about the missile's development phases hint at a broader strategy of information control. The notion that the public and military knowledge about such advanced projects can differ significantly suggests that much of the technological progress might be concealed, leading to miscalculations by other nations about the true capabilities of potential adversaries. 7. Potential redefinition of air combat. The anticipation that this hypersonic missile could redefine air combat raises questions about existing air defense systems' efficacy. The assumption that current technologies can adequately counter all emerging threats may be overly optimistic. The implication is that military planners must consider developing new strategies and countermeasures, which can be both costly and time-consuming. 8. Global response to military innovation. The urgency reflected in the development timeline may prompt rapid innovation cycles within other nations' military technologies, leading to a potential arms race. This notion contradicts the expectation that military developments would proceed at a measured pace, emphasizing the unpredictable nature of modern military advancements. In conclusion, the implementation of China's hypersonic air-to-air missile by 2025 reveals a complex interplay of budget management, technological innovation, strategic planning, and geopolitical dynamics that challenges conventional wisdom and expectations surrounding military advancements. In the context of the report detailing China's hypersonic air-to-air missile implementation by 2025, several critical elements might be easily overlooked. These elements, while not always at the forefront of discussions, underscore the significance of this technological advancement within the broader geopolitical and military landscape. 1. Budget and resource allocation. While the report mentions a $15 million budget for development, many may not fully appreciate the implications of this budget relative to the complexity and potential impact of hypersonic technology. This amount may seem modest compared to the vast sums typically allocated for defense projects, especially given the extensive R&D costs associated with advanced weaponry. However, this budget indicates China's strategic prioritization of hypersonic capabilities, reflecting a focused approach that leverages innovative technologies such as AI and machine learning within a constrained financial framework. Significance: this suggests a rapid advancement in missile technology that could catch rivals off guard, particularly if they are investing significantly more but not achieving comparable technological breakthroughs. This budget allocation also highlights China's intent to maximize efficiency and effectiveness in weapon development, which can lead to faster deployment and operational readiness. 2. Integration of AI in advanced guidance systems. The report emphasizes the integration of advanced guidance systems, likely employing AI and machine learning. While many readers might focus on the hypersonic speeds and maneuverability of the missile, the underlying technology that could enhance targeting accuracy is pivotal. AI's role in processing vast amounts of data in real time to improve decision-making and strike precision may be underestimated. Significance: this development could fundamentally alter air combat dynamics, enabling quicker, more accurate responses to threats and potentially nullifying traditional air defense strategies. The ability to adapt and learn from engagements could provide a significant tactical advantage in conflicts, creating a new paradigm in aerial warfare. 3. Geopolitical context. The report mentions rising tensions in regions like the South China Sea but may not delve deeply into the specific geopolitical ramifications of deploying hypersonic missiles. The potential for these missiles to alter regional power dynamics and provoke responses from adversaries, particularly the United States and its allies, is profound. Significance: the introduction of such advanced weaponry could lead to an arms race, compelling other nations to accelerate their own hypersonic and missile defense programs. This could destabilize existing treaties and agreements on arms control and escalate military posturing in sensitive regions, thereby increasing the risk of conflict. 4. Operational phases and timeline. The development plan is outlined in 4 phases: research, prototyping, testing, and operational deployment by 2025. While this timeline may seem straightforward, the rapid pace of development requires not only technological readiness but also organizational and logistical capabilities. Significance: the ability to meet this timeline indicates a robust military-industrial capability that can rapidly transition from concept to deployment. It also raises questions about the readiness of adversaries to counter such developments in a similarly rapid timeframe. The implications for military strategy, including preemptive actions or countermeasures, are significant as countries assess their responses to this new threat. 5. Potential for redefining air combat. The report concludes by stating that the successful implementation of this missile could redefine air combat. However, the transformative nature of hypersonic technology on existing military doctrines and tactics is often understated. Significance: hypersonic missiles can evade current missile defense systems, which could lead to a re-evaluation of air defense strategies globally. This may force nations to invest in new technologies and develop novel doctrines that incorporate rapid response capabilities and multi-domain operations, fundamentally changing how air power is projected and countered.
Conclusion.
In summary, the overlooked aspects of China's hypersonic air-to-air missile program, budget implications, the role of AI, geopolitical ramifications, operational timelines, and the potential redefinition of air combat highlight the broader significance of this initiative. As nations monitor these developments, the strategic landscapes will inevitably shift, prompting adaptations in military thinking and planning. The interplay of technology, budget constraints, and geopolitical strategy will define the nature of future conflicts and military preparedness. The implementation of China's hypersonic air-to-air missile by 2025 is a significant development within the global defense landscape. Based on the provided content, 4 key points stand out for in-depth analysis and discussion. 1. Development phases and strategic goals. China's hypersonic missile project is structured into 4 essential phases, each aimed at achieving specific milestones. The focus on advanced guidance systems, including the potential integration of artificial intelligence (AI) and machine learning, highlights the strategic goal of creating a missile that can outperform existing air-to-air options. The importance of these phases lies not only in the technological advancements expected but also in their implications for military strategy. The timeline, from initial research and development in 2023 to operational capability by 2025, illustrates China's aggressive pursuit of hypersonic technology amidst rising geopolitical tensions, particularly in contested areas like the South China Sea. 2. Technological integration and innovation. The project's emphasis on advanced guidance systems indicates a shift towards more sophisticated missile technology that leverages current innovations. This includes the potential use of AI to improve targeting accuracy and operational effectiveness, particularly in complex environments where traditional systems may falter. The integration of multi-source information for real-time operational decision-making could redefine the nature of aerial combat, making it crucial for analysts to explore how this technological evolution will affect existing air defense networks and the countermeasures they may require. 3. Geopolitical context and implications. The missile development is not occurring in a vacuum. It reflects broader geopolitical dynamics and military advancements by other nations, including the United States and its allies. The recognition of heightened tensions in the Asia-Pacific region, especially related to military capabilities, underscores the strategic importance of hypersonic technology. A discussion focusing on how this missile system could alter the strategic balance in air power, influence military doctrine, and potentially spark an arms race in hypersonic weapons will be vital for understanding the future landscape of international military relations. 4. Differing perspectives on capability and threat. The variance in how different sources report on the missile's capabilities, some focusing on technical specifications while others consider the strategic implications, highlights an essential aspect of defense analysis. The distinction between viewing the hypersonic missile solely as a technological marvel versus a transformative military asset capable of reshaping air defense paradigms reveals the multifaceted nature of military investments. Engaging with these differing perspectives can offer a more comprehensive understanding of both the perceived threats from such advancements and the potential responses from other military powers, fostering a broader dialogue on defense strategies. In conclusion, China's hypersonic air-to-air missile initiative encapsulates a convergence of technological innovation, military strategy, and geopolitical dynamics. Each of these 4 points warrants thorough examination to fully assess the implications of this ambitious project and its potential to reshape modern warfare. 1. The Manhattan Project 1942–1946. This was a research and development project during World War II that produced the first nuclear weapons. The project was led by the United States with support from the United Kingdom and Canada, and it involved significant advancements in physics, engineering, and materials science. The program included various phases such as theoretical research, the construction of production facilities, and the testing of atomic bombs. The successful detonation of the first atomic bomb in July 1945 marked a pivotal moment in military strategy and global geopolitics, leading to the eventual use of atomic bombs in Hiroshima and Nagasaki. 2. The Apollo Program 1961–1972, initiated by NASA. The Apollo program aimed to land humans on the Moon and bring them safely back to Earth. The program consisted of several key phases, including the development of the Saturn V rocket, the Apollo spacecraft, and the lunar module, as well as extensive testing in unmanned missions leading up to the manned lunar landing. Apollo 11 in July 1969 was the first successful manned mission to land on the Moon, showcasing advanced technologies in navigation engineering and materials science, while also serving as a demonstration of American technological superiority during the Cold War. 3. The Strategic Defense Initiative 1983, proposed by President Ronald Reagan. The Strategic Defense Initiative (SDI) aimed to develop a system for protecting the United States from nuclear missile attacks through a combination of ground-based and space-based systems. The initiative emphasized advanced technologies such as missile interception and laser systems and was divided into multiple phases, including research, development, and testing. Although the SDI faced criticism and skepticism regarding its feasibility and effectiveness, it played a significant role in the U.S. defense strategy during the Cold War and influenced the direction of defense spending and technological innovation in the following decades. Future outlook: predictions for China's hypersonic air-to-air missile implementation by 2025. As we approach 2025, the implementation of China's hypersonic air-to-air missile system is expected to undergo significant advancements across 4 key phases. With a dedicated budget of $15 million, China's strategic focus on hypersonic technology reflects an urgent response to evolving global military dynamics. Here we outline predictions regarding the future implications of this missile system within the broader context of international defense and technological innovation. 1. Enhanced military capabilities. Operational advantages. The hypersonic air-to-air missile is projected to dramatically improve China's aerial combat capabilities. Its speed, maneuverability, and advanced guidance systems, potentially incorporating AI and machine learning, are anticipated to outpace conventional missiles, thus providing a strategic edge in aerial engagements. Shift in air combat doctrine. The introduction of hypersonic missiles will likely prompt a re-evaluation of air combat strategies not only within China but also among its adversaries. Traditional air defense systems may become increasingly obsolete, necessitating the development of new tactical frameworks focused on countering hypersonic threats. 2. Geopolitical implications. Regional tensions. The rollout of this advanced missile system is expected to exacerbate existing tensions in the Asia-Pacific region, particularly concerning territorial disputes in the South China Sea. Neighboring countries may feel compelled to enhance their military capabilities in response, leading to an arms race in hypersonic technology. U.S. and allied responses. In light of China's advancements, the United States and its allies will likely accelerate investments in hypersonic technology and missile defense systems. Collaborative efforts among NATO and regional partners could emerge to counterbalance China's growing military prowess, potentially leading to new defense treaties or alliances. 3. Technological innovations and economic impact. Research and development synergies. The development of hypersonic missiles could drive technological advancements beyond military applications, influencing sectors such as aerospace, materials science, and artificial intelligence. Collaboration between military and civilian sectors may yield innovations that benefit broader economic interests. Investment in defense industries. The focus on hypersonic technology will likely stimulate growth in China's defense industry, leading to increased employment and technological capacity. As demand for advanced weaponry rises, companies specializing in missile technology, AI, and related fields may see substantial investment opportunities and expansion. 4. Global arms control dynamics. Challenges to non-proliferation efforts.
As hypersonic missile technology proliferates,
global arms control frameworks may face significant challenges. The increasing accessibility of hypersonic technologies could undermine existing non-proliferation treaties, prompting calls for new agreements tailored to address the unique characteristics of these weapons. Potential for arms race. The advent of hypersonic capabilities may lead to a global arms race reminiscent of the Cold War era. Countries may rush to develop or acquire hypersonic systems, complicating diplomatic efforts aimed at reducing military tensions and enhancing global security. Conclusion. The successful implementation of China's hypersonic air-to-air missile by 2025 is poised to reshape military dynamics and geopolitical relations in profound ways. With enhancements in military capabilities, potential shifts in air combat doctrine, intensified regional tensions, and implications for global arms control, the effects of this development will be far-reaching and multifaceted. As nations respond to these advancements, the landscape of international security will continue to evolve, necessitating adaptive strategies and robust diplomacy to maintain stability in an increasingly complex world.